Hello guys, good to see you back. Once again, I am back with a new project, and today in this project we are going to perform live face swapping with the help of OpenCV and MediaByte module. And it is the most complex and advanced project I ever worked on. So without talking too much, let me show you the live demonstration how we can swap our faces with multiple famous faces. So as you can see in my current working directory, we have some famous faces such as Bill Gates, Donald Trump, Dwayne Johnson, Elon Musk, Steve Jobs and Will Smith. And I'm going to swap my faces with them. And for that we are going to use live webcam. So let's back to the code and run the code in our terminal. So after run the code in my terminal, we need to wait for some time to start my webcam. After start the webcam, now you can notice my face is swapped with Bill Gates face. If I turn my head, if I open my mouth, also it match with my facial reaction. Then if I change the image, if I change the source file, now you can notice my face is replaced with Steve Jobs face. It swapped my face with Steve Jobs. Then if I change the source image, again you can notice my face is replaced with Donald Trump face. At the same way, if I change the image, this time my face will replace with Dwayne Johnson face. And it's pretty accurate. Also you can notice there is no too much distortion. If I change the image again, now my face is replaced with Will Smith face. And it's pretty accurate. Also you can see the mask in this blank window, new face window. So this is what we exactly create in this project. I hope now it's clear for you. And we are going to use in live webcam to do that. To create the project and extract the face landmark, we use MediaByte. MediaByte solution function, not the task API. Also you need to use masking, triangulation, Delaunay triangles, seamless cloning, wrapping, etc. It is not an easy project for a beginner because you should have knowledge of triangles such as Delaunay triangles. You need to understand how Delaunay triangle works. Here in this project I try my best to explain the concept with easy way. So without talking too much, let's start the practical and see how we can create this one. But before you start coding, let me introduce you something. If you want to learn OpenCV, then you can try out this course. Mastering Python OpenCV with 33 real-world project. As you can see, it is the highest rated and bestseller course on Udemy. Till today, it's come with more than a 16+ hour content, 80 downloadable resources and various projects. And these are the project list that I'm going to teach in that course. This course is completely beginner friendly. If you have little bit knowledge about Python syntax, you can enroll this course. So don't forget to check out this course for once. I will provide the link at my description. So finally, I am in my Visual Studio Code Editor. And as you can see in my current working directory, there is a folder called Images. And if I open this folder, let me show you. Here we have the famous faces, such as Bill Gates, Donald Trump, Dwayne Johnson, Elon Musk, Steve Jobs and Will Smith. So I am going to swapping my own face with them. That's why I stored in a folder called Images in my current working directory. Then after that, I am going to define a Python file. I'm going to create a Python file app.py. With that, I am going to create a helper file. I'm going to create a custom helper module file. For that, I'm going to define a folder name and our folder name is common. Here I create a common folder. Then inside that folder, I'm going to define a Python file. And our Python file name is mediautils.py. So this is our main file and this is our helper module file, which is stored in that folder named common. And in my images folder, we have the images. Now one by one, I am going to import the important libraries such as CV2. Some type import CV2. It is our main module where our program based on. After that, I'm going to import NumPy. I'm going to import NumPy as NP. Next, I'm going to import the media util file which I created earlier from this common folder. So here I'm going to type from common, I'm going to import media utils. As I told you, it is a custom helper module that's going to detect facial landmarks using media pipe, perform triangulation, warp triangles, also the blending faces seamlessly, and many more. After that, we need to set up the webcam. We need to define the dimension of our webcam width and height. For that, I'm going to define width and height. Some type width 400 and 640 pixel and height 480 pixel. Then we need to capture from our webcam. For that, I'm going to type cap variable cap equal to cv2.video capture method, and I want to open our default webcam, that's why I pass 0. And in our second parameter, we call this function cv2.cap_dshow. Now the question is, what is the usage of it? Basically, it improves camera stability on Windows operating system. That's why we need to use it. And here I use smaller resolution because we need better real-time performance. That's why we use a smaller resolution. Next, we need to set the height and width to this capture variable. So here I'm going to type cap.set method. In the set function, using 3, we define the width, and using 4, we define the height. Then I assign the height and width variable value. After that, I'm going to create a list that's going to store all the images. And our list name is source_image paths equal to, inside the square braces, here we need to pass the image paths that we are going to use for face swapping. So if I open images folder, we have all the images. So I'm going to fast forward the process and put all their image file path to this list. So I'm going to fast forward the process. So one after another, here I put all the file paths. Basically, it is a list of static image which is used for source faces. Each image will be swapped onto the webcam face. Also, if we store it in a list, then it allows switching faces using our keyboard. After that, we need to read all the images from the disk. Also, we need to store them in a list for quick access. For that, here I'm going to define another empty list. And our variable name is, and our list variable name is source image. Then I'm going to run a for loop. For image path underscore path in source image path. For image path in source image path, then inside this for loop, I want to extract every image. Using this for loop, I want to read the images one by one, and I want to store it in a variable. So here we type image equal to cv2.imread method, and here I'm going to pass the exact image path to read the image, to read the particular image. Then we need to append the image to this empty list. So here I'm going to type source image dot append method, and inside the round braces I'm going to pass the image. After that, we need to define a function. That function prepare a source face image for face swap, otherwise face morphing operation. So here I'm going to define a function, and our function name is def set source image. And as a parameter, we need to pass the exact image in this function. For now, in that function, here I'm going to type pass, because we need to do a lot of stuff in our media utility files. Otherwise, this function becomes very huge. If we try to do all that stuff, such as facial landmarks, build face mask, and computing the triangles, if we try to do all of this in that function, then it's become so huge. So I'm going to do all the media stuff in that file, media utils files. So for now, I'm going to type pass here. And remember, this function takes only one image, usually a face image. So this is the first part of this tutorial, and the next part of this tutorial we are going to working on mediautils.py file. So thanks for watching this video. Stay tuned for our next tutorial. Hello guys, good to see you back. Before I work on this function def set source image, we need to create some supported functions in our media utils file. So let's jump into the media utils file. At first we need to import the important modules such as CV2, MediaPipe, NumPy and another module called SYS. So here I am going to import all the necessary modules. You are already familiar with other modules such as CV2, MediaPipe, NumPy etc. But here I import another module called SYS. It is used to exit the program if more than one phase is detected. We use this module because in critical errors we need to exit the program. So whenever critical errors occur, we need to exit the program. Otherwise our program can become very heavy and it take more RAM, processor, etc. Next, we need to create a program that going to get the landmark points from our face. But before, we need to initialize the MediaPipe face mesh utilities, such as to drawing landmarks, connections and annotation on image or frames. Here we need to call some function from MediaPipe. So here I'm going to define a variable and our variable name is mpDrawing. mpDrawing equal to MediaPipe mp dot solutions. From solutions, I want to call this class function drawing utils. Basically, it is used to visually draw face mesh and points and lines. After that, we need to define the drawing style. So here I'm going to type mpDrawing underscore style equal to mp.solution.drawing style function. Basically, it provides ready-made color, thickness and style for landmarks and their connections. And it saves time by avoiding manual styling. And at last, we need to import the face mesh solution itself. For that, I'm going to define another variable and our variable name is mp underscore face underscore mesh mp.solution face mesh. This function going to detect the facial landmarks, something 468 points, otherwise 478 with redefined landmarks. Let me show you the example. So here you can see an image MediaPipe face mesh solution. This is how MediaPipe read our face. These are the landmark points that MediaPipe reads from our face. And after detect the face and draw the landmarks in our face, this is how our face look like. It draw a mesh mask over our face. We already have the knowledge about it in our previous project, so I'm not going to explain it here. Now let's back to the code again. Next, we need to get landmark points and here I'm going to define a function. For that, I'm going to type def get landmark points and as a parameter I'm going to pass the image source. Basically, this function going to detect 468 facial landmarks and it convert them into pixel coordinate. Then inside that function we need to create a face mesh object. To create that, I'm going to type with mp underscore face underscore mesh. From MediaPipe face mesh, here I access this function called face mesh, and inside this function I pass some parameter and I open as face mesh. I create an object with this function face mesh object, and as you can see in this function we pass some parameters such as static image mode. Static image mode is true. It means here we use single image, not video. It tells MediaPipe that each image is independent. Also, it is best for single image or image processing task, but slower for video. Next, we define the maximum number of face. Here I use 1. It's going to detect only one face, so it's faster and perfect for face swap. And for high precision landmarks, here I use this parameter called refine landmarks. Refine landmarks equal to true. And then we define minimum detection confidence equal to 0.5. And in that parameter we need to pass value between 0.0 to 1.0. If we pass higher value, it going to return more accurate result, but it can misses face. But if you pass lower value, it detect more faces and less reliable. Most balance is 0.5. And with the help of these functions, here we create an object, a face mesh object. Then inside it, after that, we need to convert the object into BGR to RGB mode, RGB color mode. So here we type a single line comment, convert the VGR image to RGB before processing. And here I'm going to type results equal to facemesh.process method, and using cv2.cvd color method we change the color mode of our frame, because by default OpenCV use BGR color mode. It's working BGR color mode, but for MediaPipe we need to use RGB color mode. After that we need to print and draw face mesh landmark on the image. But before, I'm going to set some conditions. I'm going to set, if no face is detected, then I want to stop our program. I want to stop this function. So here, if not results dot multiface landmarks, then return none. It means if there is no landmark on the frame, then stop it. Also, I'm going to set another condition. If there is more than one face, in that case also I'm going to stop executing our program. For that I'm going to type if length multiface landmarks greater than 1. In that case, inside the if statement, I'm going to use a function. I'm going to use a function from this module called sys. So type sys dot exit, and I'm going to type there are too many faces. It already suggests me to type too many faces detected. After set up the condition, we need to convert the MediaPipe face mesh landmark into pixel coordinates and store them as x and y points. But before, we need to get the first detected face landmarks. So here I'm going to define a variable source face landmark. Source face landmarks equal to results.multiface landmarks, and inside the square braces I'm going to pass the first index number 0. I'm going to pass the index number 0 dot landmark. This function results.multiface landmarks returns list of detected face, and as you can see inside the square braces I pass 0. It's mean the first face. Since we mentioned only one face is allowed, so it's going to return only one face. So at index number 0 it store the face. And after dot, here we call landmark function, and landmark contain 468 face landmark points, and each landmark has normalized coordinates x, y, and height and width. Then I'm going to create an empty list to store the pixel points. Next I'm going to look through all the landmarks, all the 468 landmarks. So here we type for I in range of 468. Then inside this for loop, x coordinate equal to int source face landmark. Here I convert the landmark points into pixel coordinates, the actual image pixel coordinates. Now let me explain the concept, what we have done here, how we can calculate it and extract the pixel values. Now let's try to understand how we can extract this x-axis pixel value. As I told you earlier, MediaPipe gives landmark points in normalized coordinates. X and y are float between 0 to 1. So if I move x-axis direction, we have value between 0 to 1.0. Also, if I move y-axis direction, we have value between 0 to 1.0. 0 represent the top left corner of the image. It's represent the starting point, and 1 represent the bottom right of the image. It is the end point of our image area. So they are relative to the image size, not pixel values. So whatever image size we use, it's not going to matter. It's going to divide the value between 0 to 1. Now we need to convert them into pixel point. In our case, I would like to go with x-axis. As you can see here, I type source face landmark dot x. It's going to normalize the x coordinate into 0 to from 0 between 1. Then we have another function sourceImage.shape. It provides the image width in number of columns. Now we need to multiply to get the x position. So here I multiply it. Here I multiply both the values and convert them to integer. Suppose our one of the landmark coordinates value is 0.6. MediaPipe return this value 0.6 and our frame width is 640. If I want to convert it into pixel coordinates, then we multiply 0.6 width of this frame 640 and it's going to return the exact x-axis coordinate point 384 pixel. At the same way, for the y-axis we need to multiply with image height. So whatever value we get from y-axis, we need to multiply with image height and it's going to return the y-x coordinate. So this is what we exactly do the same thing to get the value. 1 represent the width of our image and 0 represent the height of our image. Then after get the x-axis and y-axis pixel value, we need to append the landmark point into this empty list. So here I type landmarks the underscore points dot append method and I append both the values, both the pixel values. Now the question is why it is important. Using that, if we have the exact point, exact pixel value, we can draw circles, we can create triangles, we can compute the convex hull, also we can perform phase swap. Now after append it, our function, our main function, I want to say, our function get landmark points going to return the landmark points. So I'm type return landmark points. And using that function, we get the landmark points from our image. Just try to understand what you do in that function, get landmark points. As you can see, as a source is going to take a image. As an input, we pass a Bezier color image. Next, we convert the image into RGB color mode. After that, we initialize the face mesh and we allow maximum number of face 1 and refine landmark true. Then it's going to detect the face and check for one face and extract and convert the points into pixel coordinates. And at last, it's going to return the landmark list. So this is what we exactly do in that function. It's going to process the image and extract the face landmarks. I hope now the concept is clear for you. What is the actual usage of this function? Thanks for watching this video. Stay tuned for our next part. Hey guys, good to see you back. This is another tutorial related to this project, and today in this project we are going to create another function. We are going to working on another function. We are going to working on getTriangle function. But before we need to create a function to extract and return the first value from a NumPy array. Specifically the first element of the first row. For that I'm going to define a function. So here I'm going to type def and our function name is extract index NumPy array, and inside the round braces I'm going to pass a NumPy array. This function going to accept a NumPy array as an input. Then I'm going to initialize a variable and our variable name is index. Index equal to none. After that we need to loop over the first row. For that here I'm going to use for loop for num in NumPy array and I'm going to pass the index 0. 0 means the first row of the NumPy array. And then I assign the first element and stop the loop. Index equal to num and then I break the loop. So wherever the first element is taken, it's going to stop the loop immediately. After that, outside the loop, it's going to return the index. That's it. Its purpose is to simplify NumPy output by extracting a single index from it. After that, we need to create a function that's going to get the triangles using Delaunay triangulations. So let's define the function. And our function name is def getTriangles. And as a parameter, here we need to pass convex hull, landmark points, and NumPy points. As I told you, this function uses Delaunay triangulation and also generate triangles inside the face convex hull and convert triangle pixel coordinate into landmark indices. This function is very essential for accurate face swap, face morphing and seamless cloning. Now let me explain what is Delaunay triangulation and what is the exact usage of this function. Now let me explain what is the purpose of getTriangles function. The purpose of getTriangle function is to convert facial landmark point into a consistent set of Delaunay triangles represented by landmark indices. So the same triangle structure can be used for face swapping or face morphing. In one sentence, it created Delaunay triangle on a face and returned them as landmark index triplets, not pixel coordinates. So as you can see in this example, we have number of points and it is the example of Delaunay triangle. And this is the example of non-Delaunay triangle and you can see the difference between them. And this one is also example of Delaunay triangle. Now the question is why this is needed, why it's important. In face-based application like face swap, face morphing, seamless cloning, triangle-based wrapping, you cannot directly wrap a whole face at once without distortion. Instead, the face is divided into small triangles and each triangle is wrapped individually. And as you can see in this example, each of the triangle is wrapped individually. Now the question is what the function does internally. It takes all facial landmark points, build Delaunay triangulation inside the face convex hull. The area you can see which is wrap up the face, it's known as convex hull, and inside it you can see it wrap all the triangles. It is Delaunay triangulations. After that, it convert each triangle points into landmark indices and return a reusable triangle map, something like that. And if we talk about what our function exactly return, it's going to return these numbers such as I1, I2, I3, I4, I5, I6. Each of the list represent one facial triangle. So this is list number 1 and this is list number 2. Each of the list represent one triangle, one facial triangle, where I1, I2 and I3 are indicates of landmark points. Now let's try to understand what is Delaunay triangulation. Delaunay triangulation is a technique that divides a set of points into triangles in the most stable and natural way possible without creating long and skinny triangle. In simple definition, Delaunay triangulation connects points to form triangles such that no point lies inside the circle of any triangle. Now the question is why Delaunay triangulation is important. It ensures triangles are as close to equilateral as possible, stable for deformation, free from thin and stressed shape, and that's why it's heavily used in face wrap, face morphing, 3D modeling, computer graphics, and many more. And why it is perfect for face swap? Because faces differ in size, angle, and expression. Wrapping triangle by triangle must remain smooth. And Delaunay triangulation preserves local geometry, keeps facial features aligned, prevent cracks or overlaps. It converts facial landmark point into a consistent set of Delaunay triangles represented by landmark indices. So the same triangle structure can be used for face swapping and face morphing. Now the concept is clear for you. I don't want to jump into the mathematics because it is pretty complicated to understand it. So let's start the practical and build the function. Now once again I'm back to the function. And as you can see, this function take total 3 parameters: convex hull, landmark points, and NP points, numpy points. At first, we need to bounding the rectangle face. For that, here I'm going to define a variable called rect. RECT. Rect equal to CV2 dot bound rect. and inside the round braces here we pass the convex hull parameter. Convex hull represents the outer boundary of the face, and the function bounding react creates a simplest rectangle that contains the whole face in it. Now the question is why we need to do that? Because to create the Delaunay object, we need this rectangle. Next, we need to create subdivision object. I mean the Delaunay. For that, here I am going to define another variable, and our variable name is subdiv. Subdivision equal to cv2 dot subdiv, s should be capital, subdiv 2d, and inside the round braces I pass the rectangle, because this function require a rectangle region to work in. Now all the triangle will be created inside the rectangle. Here we initialize Delaunay Triangulation. After that, we need to insert the landmark points. We need to insert the landmark points into the subdiv. So here I am to type subdiv dot insert method, and inside the round braces I am to pass the landmarks points. And remember, landmark point is a list of x and y axis facial landmark coordinates, and subdiv connect those points into Delaunay triangles. As you know, it is the rule of Delaunay. No point lies inside the circumcircles of any triangle. This will ensure stable triangles, no long or skinny triangle. Now let's get the triangle list. For that, here I am to type triangles equal to subdiv dot getTriangle list. It's going to return the triangle as x1, y1, x2, y2, x3, y3, something like that. Next, we need to convert it into NumPy array for easy processing. And to do that, again I'm going to type triangles equal to np array. Inside the round braces, I'm going to pass the triangle itself, and doc type equal to np dot int 32. It's going to convert the NumPy array in a number. Let me explain what it's going to exactly return. First, the triangle list, getTriangle list, it's going to return the value like this: x1, y1, x2, y2, x3, y3. Now we need to convert it into numbers using the array, NumPy array. And after convert it, it's going to return value. It's going to return value like this: the numbers, the exact numbers. After that, I'm going to create an empty list to store the indexes triangle. So I'm going to type indexes triangles equal to empty list, and then I want to run a for loop to each triangles. And remember, this list going to store triangle as landmark indices instead of coordinates. Now let's run a loop through each of the triangles. So here I'm going to type for t in triangles. Here each t contains 6 value. I want to say 3 points. So inside the for loop, here I convert flat array into 3 tuples. T is one triangle written by the triangles, and each triangle is stored as a flat list of 6 values, such as x1, y1, x2, y2, y3, x3 and y3. Total 6 value. So it represents 3 points. 3 points of a triangle. Because to make a triangle, we need total 3 points. Then we extract the points x-axis and y-axis value. Our first index stands for x-axis, and our second index of t stands for y-axis. This is the first vertex of triangle, this is the second vertex of triangle, and the last one is the third vertex of the triangle. Next, we need to find the landmark index for each point. So one after another, I find the landmark index for each point. Now, what we have done here, such as index point 1 equal to np dot where method. Using where method, we can search which row matches these points. And inside the round braces, np points represent NumPy array of landmark coordinates, and it's equal to pt1 points 1. Then after that, we call a function. Index part 1 equal to, we call a function that we create earlier, extract index NumPy array, this one. And as I told you, it's going to return the first indices. So it's going to convert the result into single index. Basically, here we finding the index of point inside a NumPy array of points. NP points represent a NumPy array of shape. Example, NP point contained total 3 list items inside the list, and each list item is a list. Let me clear the concept with practical way. Now what is happening here? NP point represent a NumPy array of shape, and it is just a shape notation of NumPy array. And in this array we have total 3 point value, and every value contain total 2 value, and equal to pt, and pt represent a single point like this. And this condition compresses pt1 with every row and produce a boolean array. And using this method .allAccess1, it checks row wise quality. It's written true only where both x and y matches. So it's matched with this point. So it's going to, at that condition, it's going to return true. And the np where method return the exact index where the match is found. Next, after found the match of the index point 1, we need to extract the first actual index value with the help of this function, extract index NumPy array. This function extract the first actual index value because using np where method we store it in a tuple, and from this tuple we extract the first index value. Now the question is why it is important. In Delaunay triangulation, you get triangle vertex coordinates, but to wrap triangles you need indices of landmark points, and this code convert x and y landmark index. I don't want to deep dive into it because it is too much complicated to understand. After that, we need to validate the triangle, and it is important. For that, I'm going to use if condition. So here I'm going to type if index pt1 is not none and index pt2 is not none and index pt3 is not none, then inside this if condition, we need to store the triangle indices. Basically, it is an important check. Sometimes triangles falls outside of the face and point did not match exactly due to rounding. And this will ensure all 3 points belong to validate facial landmark. And this make it reusable for source face and destination face. After that, I'm going to outside the for loop. Outside the for loop, I'm going to return the index triangle. So I'm going to type index return index triangles. So why this function is important? It keeps same triangle structure for both faces, enable perfect triangle wrapping, and prevent distortion. It is the industry standard approach for face swap. Basically, in that function, we convert triangles to landmark indices, something like that. As you can see, we have face landmarks, and after apply Delaunay triangulation, we find the landmark indices. Then extract the index of it. Now we have index triangles and also we have landmark points. So using these two parameters, we are going to perform triangulation. So at the next function, we are going to create triangulation with the help of triangle index and landmark points. So this is it for this tutorial. Thanks for watching this video. Stay tuned for the next part of this tutorial. So in our previous tutorial, we worked on getTriangles function, and now in this tutorial we are going to working on triangulation function. So here I'm going to define a function, and our function name is def triangulation, and in this function we need to pass total 3 parameters: triangle index, landmark points, and image. By default here we set image none. Now let's talk about the importance of this function. Basically, this function going to break the face into small, manageable triangles so we can accurately reshape, warp, and blend faces without distortion. And as you can see in this function, here we pass total 3 parameters: triangle index, landmark points, and image. Triangle index. It is a list, otherwise a tuple, of 3 indices. And these refer to indices of face landmark that form a one triangle. Then come landmark points. It is list of coordinates of all facial landmarks such as x and y axis coordinate. And last we have image. It is optional. If we provide the image, then triangle will be cropped from image. So after facial landmark triangulation, our face look like this. Before, only with landmarks, you can see only the points, landmark points in our faces. But after triangular mesh overlay, it joins all the points with each other using triangles and create this triangular mesh with the help of triangulation. So in one line, this function is important because it breaks the faces into small, manageable triangles so we can accurately reshape, warp, and blend faces without distortion. And the real problem it solves, imagine this situation. If you try to wrap or swap a face as one big frame, face can stretch unnaturally. Also, nose can blend when we move our mouth. Also, eyes can drift, and alignment become impossible. Faces are not flat rectangles. They are complex curved surface. So if we do not use this function, we can face these kind of problems. Now, what this function specially enables? It converts global faces into local triangles. This function takes 3 landmark points, create one triangle, work on small area instead of full face, and as a result, it can give you precise control. Without this function, you cannot properly do rectangle-based face swap. You cannot do Delaunay triangles. You cannot apply affine wrapping correctly. You cannot avoid facial distortion. You cannot align two different faces. Also, you cannot handle rotation or scale. In simple student language, this function prepares each facial triangle so that OpenCV can wrap and blend it accurately. Without it, realistic face swapping is impossible. So let's back to the function and build the function. Now inside this function, we need to extract the triangle landmark points. I want to say the triangle points. And we need to convert the landmark indices into actual pixel coordinate. For that, here I'm going to type a variable name triangle1 tr1 underscore point 1. From triangle 1, I want to extract the point 1 pt1 equal to, here I want to type landmark points, and from the landmark points, I want to extract triangle index number 0. And at the same way, I am going to extract two other pixel coordinates. And from the triangle index, we extract index number 0, index number 1, and index number 2. And we store it in these variables. Let me explain what we had done here, what we try to say. So I create a multi-line comment and let me explain what we store in these variables. Suppose we have triangle index, and triangle index store these three values 10, 25, 40. And one by one we extract the value and store it in that variable. So every value from the triangle index we store it in that variables. Now let's remove that. After that, we need to create the triangle array. So here I am going to type triangle equal to np array. From numpy we call array function, and here we create an array. Here we create a numpy array of triangles. And if you are working on OpenCV, then np.intype32 is required. And remember, here we store 2D points, x-axis and y-axis coordinates. And in that array we pass the 2D points, 3 2D points. Here we group the 3 points together and represent one triangle. Next, we need to bounding the rectangle of triangle. For that, I'm going to define a variable called rect equal to cv2 dot bound rect, and inside the round braces I pass the triangle. And now the question is, what does the variable store? It contains tuple of 4 values: x-axis, y-axis, width and height. Because as you know, to create a rectangle of our face or any position, we need the starting point. So from the x-axis and y-axis we can define the starting point, and from width and height we can define the end point. So I'm going to store it in a variable. So I type x-axis, x, y and width and height equal to our rect variable. This will find the smallest rectangle that fully contain the rectangles. X and y represent top left corner, this corner, and this represent width w, and this one represent height h. It is used for cropping and local coordinate mapping. Now after bounding the rectangle, we need to crop the rectangle area from image. So at first I am going to define a variable, and our variable name is cropped rectangle. Cropped rectangle equal to none. After that, I am going to set an if condition. Here I am going to type if image is not none, so if image is available, then we need to extract the rectangle area and we need to crop it. Then we need to crop the rectangle area and store it in that variable. We need to assign it crop rectangle variable. So here I'm going to type crop rectangle equal to image, and from this image area and from this image we crop the rectangle, the exact rectangle area which I extract earlier, which contain every triangle inside it. After that, outside the if condition, we need to create a empty mask. We need to create a black mask image same size as bounding box. For that, here I'm going to type a variable crop triangle mask. Crop triangle mask equal to np.zeros, and as parameter we pass height and width, and to create the mask here we pass height and width. After that, we need to convert the global points into local coordinate. For that, here I'm going to type points equal to np.array. As you know, each of these variables are triangle vertex. Here, every variables store total 2 value, x-axis coordinate and y-axis coordinate. These are the actual pixel coordinates, and using its index number, using 0 index number, we access the x-axis coordinates, and using 1 index number we can access y-axis coordinate. And now the question is, why I subtract x and y value from it? Because after cropping, the triangle coordinate must be relative to the cropped image, not the original image. Now the question is, what does this line actually create? It creates the triangle point inside the cropped image. After that, we need to fill the triangle area with white mask, white color. For that, here we need to use a method called fill convex poly from OpenCV. So I type cv2 dot fill convex poly, and in this mask we pass the crop triangle area, mask area and the points, and also the color code. In one sentence, it's fill the triangular region with white color on a mask image. Here we pass the blank mask image, usually it's a black color. We earlier create this one, and then we pass the points, and these points store 3 vertices of the rectangle. Now the triangles are become white and everything else remain black. And now to create all of it, we need to return the points, crop triangle area, crop triangle mask and the rectangle. So whatever we create using this function, we need to return off all of it. So here I'm type return points, crop triangle area, crop triangle mask and rectangle, the bounding rectangle. Points represent local triangle points, crop triangle represent cropped image region, and crop triangle mask represent binary mask of triangle. and rectangle return the bounding rectangle area, which contain all the triangles. I know the mathematics and the concept are so much difficult to understand for a beginner, but this is the actual process of perfect triangulation. Now it's become more clear what we have done here. First, we extract the triangle, and after extract the triangle, we have the triangle points. These are the triangle points, 3 triangle points. Then around the triangle points, we create a bounding rectangle box. Inside this rectangle box, we have the triangle. After that, we crop the triangle and extract the region, the exact triangle region inside this rectangle. And then we create a triangle mask. And as an output, this function return crop triangle area, triangle mask, and bounding rectangle. So I hope now the concept is clear for you what the function exactly going to do. So this is it for this tutorial. Thanks for watching this video. At the next part of this tutorial, we are going to working on another function called wrapped triangle. So thanks for watching this video. Stay tuned. Now, after work on the triangulation function, we need to work on another important function, and our function name is wrapped triangle. So here I'm going to define a function def, and our function name is wrapped triangle. And inside the round braces, here we need to pass multiple parameters. But let me explain why we create that function wrapped triangle. This function takes one triangle from the source face and reshape plus move it so that it perfectly fits into the corresponding triangle on the destination face. Next, I'm going to pass the important parameters to this function. So inside the round braces, I'm going to pass the important parameters such as rectangle, points 1, points 2, source crop triangle, destination crop triangle mask, etc. Now let's talk about the rectangle parameter. Why we use that parameter? Here rectangle represent the bounding rectangle of the destination triangle, and points 1 represent triangle points from the source face, and points 2 represent triangle points from the destination face, and both the points relative to the rectangle, and this come source cropped triangle. It is the cropped source triangle image. And next comes destination cropped triangle mask. It is the mask of destination triangle. Next, inside the function, we need to unpack the rectangle. As you know, our rectangle store total 4 value: x-axis value, y-axis value, width and height. So here I'm going to assign inside the round braces xy wh equal to rectangle. xy represent the top left corner of the triangle, and width and height represent the triangle region. After that, we need to compute the affine transformation matrix. For that, I'm going to define a variable called matrix. Matrix equal to cv2.getAffine transformation. And then we pass point 1 and point 2. Point 1 represent the source triangle coordinates, and point 2 represent destination triangle coordinate. And this method handle translation, moving, rotation, scaling and skewing. And then after that, we need to wrap the triangle. For that, I'm going to define a variable wrap triangle. Wrap triangle equal to cv2.wrapAffine. And here, as a parameter, we need to pass source crop triangle and the matrix, also width and height. After that, we need to apply the destination triangle mask. For that, again, I'm going to override the variable wrap triangle equal to cv2.bitwise AND operator. And as you know, bitwise AND operator perform operations between two images or an image and a mask. As a first mask, we pass wrap triangle. Also as a second mask, we pass wrap triangle. And mask equal to distribution copied triangle mask. Now why this step is critical? After wrapping, this image still contained extra pixel outside the triangle. This line keep only the triangle area, removes everything else. Without this mask, rectangular artifacts appear. Also, face swaps look broken. And then after that, I'm going to return the wrapped triangle. Now this triangle is now correctly positioned and ready to be blended into the new face. In one sentence, this function uses an affine transformation to reshape a source face triangle so it exactly fits the corresponding destination face triangle. Then mask it to keep only the triangular region. And here I use bitwise AND operator for the mask. At the next part of this tutorial, we are going to working on add piece of new face function. So thanks for watching this video. Stay tuned for the next part of this tutorial. Good to see you back, guys. This is the another tutorial related to our project, and at that section we are going to create another function, and our function name is def, and our function name is add piece of new face, and this function going to take total 3 parameter. At first it going to take new face, then it going to take the rectangle area and the wrapped triangle. Now let me tell you what is the purpose of this function. This function takes one wrapped triangle and blends it into the correct position of the new face image without overlapping old pixel. This function will ensure no triangle overlaps, clean stretching and smooth reconstruction of the new face. The first parameter new face is the final image where the swept face is being built, and the rect parameter bounding rectangle of the current triangle, and the third parameter wrapped triangle is the triangle already wrapped to the match destination face geometry. Then inside that function, at first I am going to extract the coordinates, rectangle coordinates. For that, again inside the round braces I am going to type x-axis, y-axis, width and height equal to rectangle. Next we need to crop the target region from the new face. For that I am going to define a variable new face rectangle area. So here I am going to type new face rectangle area equal to new face, and here we extract the region of interest area from the image new face. It's give me the only the part of new face where the current triangle should be placed. Now let's try to understand this slicing. It start at row number 1 and end at row number y plus height, and it start at column number x and end at column number x plus w, means width. This exactly match the bounding rectangle of the triangle. After that we need to convert the cropped area into grayscale. For that here I am to type new face rectangle area underscore gray, and I convert this variable into gray color using CVT color method. As you know, grayscale makes thresholding very easier and faster. That's why we need to convert it into grayscale. Next, I am going to create an inverse mask. For that, I am to type underscore comma mask triangle design equal to cv2.threshold. And here I pass the gray image and then we pass the code. In this function, first we pass the source, the image source, the grayscale image source, then we pass the threshold value, in our case 1. After that, we need to pass the maximum threshold value. Here I assigned 255. Then we pass the types, thresholding type, thresholding method type. In our case, I use cv2.threshed binary inverse. After that, we need to apply the mask to the wrapped triangle. For that, I am to type wrapped triangle equal to cv2.bitwise AND operator. And as a first source, we pass the wrapped triangle, and also for the second source, we pass the wrapped triangle. And mask equal to mask triangle designed. Mask with that. And here I want to mask with this inverse mask triangle designed. Then after that, we need to add the triangle to the face area. For that, here I'm going to type new face rectangle area equal to cv2.add method. And here I'm going to add new face rectangle area wrap triangle. Basically, this line going to combine the existing pixel in new face rectangle area with the current face wrapped triangle and create one image block. In our first parameter, we pass the pixel from previous triangle, and in our second parameter, here we pass the pixel from current triangle, and it is the masked version. And next, we need to put updated area into the new face. This is our new face, so I'm going to put the updated area to this new face variable, new face area. For that, here I will type new face dimension, and here I pass the updated area. Now one triangle is successfully stitched into the new face. Basically, this function builds faces triangle by triangle. Also, it ensures clean building and prevent triangle overlap. So this is it for this tutorial. Thanks for watching this video. Stay tuned for our next part of this tutorial. Hello guys, good to see you back. Once again, I am back with another tutorial related to this project, and at that section we are going to create another function, and our function name is swap new face. So I'm going to type def swap new face. Then inside the round braces, here I'm going to pass some parameters. This function is going to take multiple parameters such as distribution image gray, distribution convex all, and new face. So I'm going to pass all the parameters here. Distribution image is the original image where face will be replaced, and it's a color image. And distribution image gray is the grayscale version of this image. And then come distribution convexal, outline of the destination face, and then we pass new face. And here, as you can see, we already wrapped and reconstruct new face in our previous function, and we pass it here. Then at first, inside this function, I'm going to create a empty mask. So I'm going to type face mask equal to np.zeros underscore like distribution image gray file. Basically, it's going to create a black image, same size as distribution image. You can think of this a blank canvas for face masking. After that, we need to fill the face area with white color. For that, I'm going to create a hard mask, and I'm going to type hard mask equal to cv2.fillConvexPoly method. And as a parameter in this function, we need to pass face mask, distribution convex all, and the color code 255 full value. Now the convex all is filled with white color. Everything else stay black. As a result, it returns white face area and black background color. Next, I'm going to inverse the mask. For that, I'm going to type face mask equal to cv2.bitwise AND operator, bitwise NOT operator, and here I'm going to pass the hard mask. Now the black area become face and white area everything else. Here we want to remove the original face. We don't need to keep it. After that, we need to remove the original face. We need to keep everything except the face. For that, I'm going to apply masking. So here I'm going to type a variable head without face. Head without face equal to cv2.bitwise AND operator. And here I'm going to mask with distribution image with mask face. Now the face area become black. Only you can see the head portion. Next, we need to place the new face to this empty hole. For that, as a result, I'm going to type result equal to cv2.add method. And here, head without face we will replace with new face. Here we replace the old face with the new face, the empty place with the new face. Something like that. Let me show you the example. This is the example. This is our exact destination image, and after apply face mask with convex all mask, it's look like that. Then we create head without face. Then we remove the face from this area. Now you can see only the head portion. After that, After that, we need to fill the place with the new face, something like that. And next, we need to apply the seamless cloning to make it more realistic. Because after add the new face, after replace with that, edges might be look fake and hard. And so we need to blend it and make it realistic. So let's back to the code and do that. But before we apply seamless cloning, I want to say the main magic, we need to find the center of the face. For that, here I'm going to define the rectangle area. So I'm going to type x-axis, y-axis, width and height equal to CV2 dot bounding rectangle. And here I'm going to pass the distribution convex hull image. As you know, the method CV2 dot bound rectangle return the x-axis, y-axis, width and height of the rectangle. And here we pass the distribution convex hull image, and it extract this property, this dimension. X-axis and y-axis represent the corner of the rectangle. I want to say the top left corner, and this represent width and this represent height. After that, after get the properties, we need to make the face center. For that, we need to find the center position of our face. So here I'm going to type a variable called center face. Center face inside the round braces. First, we need to extract the center x calculation. Then we need to extract the center y calculation. For that, I'm going to use int method because we need to convert it into integer. So here I'm going to convert it into integer int, and inside the round braces, here I perform a calculation. X plus width and divide the value with 2. It can give you the middle portion of x-axis. X represent the left edge and x plus w represent the right edge. And if I divide it with 2, it provides the center x position. At the same way, we need to extract the center y position. So I do the same thing, but this time I add y plus h and divide it with 2. And here we extract the center y position. And now we have the center position of our face. Then after that, this function going to return and perform seamless clone. For that, I'm going to type return keyword return, and here I'm going to type cv2 dot seamless clone, and inside the round braces, it's going to return result, distribution image, hard mask, center face, and cv2 dot normal clone. All these values. In result variable, we have the image with new face. And in distribution image, we have the original destination image. And in hard mask, here we define the area to blend. And in center face, here we define where blending start. And at last we define normal clone. We use it for natural lighting and texture blending. So as a result, this function remove the original face, place the new face, and use seamless cloning to blend everything naturally. Exactly similar to this example. First we pass the destination image and create a face mask. After that, we remove the face. Then we replace with new face. And we perform seamless cloning. So I hope now the concept is clear for you why we build that function. So thanks for watching this video. Stay tuned for the next chapter. Hello guys, good to see you back. This is the another tutorial related to our project. And in our previous tutorials, we already finished our job for media utils file. We create our necessary functions and return the variables that we need. Now, let's back to the app.py file. As you can see, in that file, we create a function set source image, and as a parameter, we pass the image. Now, let's try to understand what this function actually does. This is a very important function because this is where our face swap process really begins. Now, at first, we store the source image globally because we will need it again and again to later steps like wrapping and seamless cloning. For that, I'm going to make this variable source image global. So here I will type global, and our variable name is source src image, this one, and that to the next line. Then Then after that, I'm going to set the source image. So I'm going to type source image equal to the image itself, the image we pass inside this function. After that, we need to convert the source image into grayscale, because mask and blending operation in OpenCV works based on single channel image, and its work also faster. So here I'm going to type source image gray equal to, I'm going to convert this one into grayscale color. I'm going to convert the main image into grayscale. For that, we need to use CVD color method. So I'm going to type cv2.cvd color. As the image, we pass the image source. But before I convert the source image into grayscale, I'm going to global some variables, the important variables, because we need it again and again. So for comma, here I'm going to global all of these variables, such as source image gray, source mask, source landmark points, source NP points, source convex hull, index triangle, etc. Now let's pay attention on these global keywords. Here I am declaring several variables as global, which means they can be accessed from anywhere in the program, not just inside this function. Now the question is, why do we need this? Because phase swapping is a multi-step process. We detect landmark in one function, wrap triangle in another function, and finally blend everything in different function. So instead of passing the same data again and again as function parameter, we store them globally for easy access. For example, source image store the original source face, and source image gray used for mask and blending, and source mask define the face area, and source convex hull and source triangle store all the geometric information of the face. So before I use this variable, I already make this variable global. Now to store this source image, we need to convert it into grayscale. For that, I'm going to type source src source image gray. So I'm going to copy this variable name and I'm going to store it here. Source image gray equal to cv2.cvd color. Then inside the round braces, and here I'm going to pass the source image. Source image is, sorry, there is only single image, so I'm going to remove s from it. It's image, not images, because we pass only single image. And we need to convert it, into BGR to gray color. So I type cv2.color underscore BGR to gray. As I told you earlier, masking, blending and cloning works on single channel images. That's why we need to convert it into gray color. After that, we need to create an empty face mask. Also, we need to store it in a variable. So for our variable, I'm going to take this name source mask equal to np.zeros_like. And as the image, I'm going to pass this grayscale image. Then after that, we need to detect the facial landmark points. It is the most important part, facial landmark detection. Using MediaPy face mesh, we extract hundreds of precise landmark points from the face. These points represent the eye, nose, lips, jawline, basically the entire face geometry. For that, here I am going to use this variable name source landmark points. Source landmark points equal to from media utils file. So let's jump into the media util py files. I want to access the function called get landmark points, this one. So I'm going to copy the function name get landmark points and back to app.py file. And to access this function, I'm going to type media utils dot get landmark points, this one. Then inside the round braces, as an image, I'm going to pass the source image. So to pass this variable source image. Next, we need to convert the landmark into NumPy array. For that, I'm going to use this variable name source np points. After copy this variable name, I'm going to paste it here equal to, here I'm going to use np array function, and inside this function I'm going to pass the source landmark point. After that, we need to compute the face convex hull. For that, I'm going to use that variable source convex hull. So I'm going to type source convex hull equal to cv2 dot convex hull, and inside the round braces, here I'm going to pass the source np points, this variable. Now the question is, what is convex hull? It is the tight outer boundary of the face. Let me show you the example. As you can see in this image, it's like wrapping a rubber band around the facial points. So this is exactly convex hull look like. It is outer boundary of the face. After that, we need to fill the face area in the mask. For that, I'm going to type cv2 dot fill convex poly method. So I'm type cv2 dot fill convex poly, and as a parameter, as a variable, here I pass the source mask, then we pass the source convex hull, and then we pass the color code 255, I mean fully white. So once we have the convex hull, we fill it with white color inside our mask. Now the face area becomes white and everything else stays black. This mask will tell OpenCV exactly where the face exists. Now after that, we need to move to the Delaunay triangulation. For that, I am going to use that variable index triangles. We need to extract the index triangle from this image. So here to type index triangles equal to, from media utils, some type media utils, I want to access this function getTriangles, this one. So let's jump into the media utils file. Here we create a function called getTriangles, and in that function we need to pass convex hull, landmark points and np points, and we extract all of it. So let's back to the app.py file, and from media utils I want to access media getTriangles function. Then inside the round braces, first in this function I am going to assign the convex hull. Convex hull equal to source convex hull. Then I am going to assign the landmark points. So here I am going to type landmark points equal to source landmark points. We pass the source landmark points. Then after that, we need to provide the NumPy points. For that, here I am to type np points equal to source NumPy points, this one, this NumPy n. I already explained about triangulation, Delaunay triangles in our previous tutorial, so I'm not going to explain it here how it's work. Just remember, here we divide the interface into multiple small triangles. This step is extremely important because faces are not flat. They bend, stretch and rotate. If we do not apply triangulation, then our face becomes deformed. To prevent the distortion of our face, we use that. By wrapping up the face triangle by triangle instead of as a single image, we get a much more natural and realistic face swap. And now we need to make the final call. So outside the function, I'm going to call that function. I'm going to call set source image. Set source image. Then inside the round braces, here I'm going to pass the image. So from the list, here I'm going to pass the first image. So from the source image, src source images, I'm going to pass inside the square braces, I'm going to pass the first index 0, this one. Now this will initialize the source face geometry, mask, triangle for the entire face swap pipeline. So this is it for this tutorial. At the next tutorial, we are going to start our loop. So thanks for watching this video. Stay tuned for our next tutorial. Good to see you back, guys. This is the another part of this project. And in that section, we are going to start our main loop. For that, I'm going to start a while loop here. So I'll type while true, while the condition is true, then inside the while loop, at first, I'm going to make all the variables global. So copy that line, the exact line, and I'm going to make all the variable global because we need to use it again. Now at first inside this while loop, we need to read the frames. At first we continuously read the frames from the webcam using cap.read method. So here I'm going to define total two variables. First variable going to store a boolean value and the second variable store the actual frame which we get from the read method. So type underscore distribution image equal to cap.read method. After that, we need to resize the frame and set fixed width and height. For that, I'm going to use resize method. So here we type distribution image dist underscore image equal to cv2.resize, and I want to resize the distribution image itself. Then I define width and height. If I scroll up the page, here you can see here we define width and height. Width 640 pixel and height 480 pixel. Then back to the code again. We do that because it will make our processing faster. Next, we need to convert the frame into grayscale color. For that, here again I'm going to type a new variable distribution image gray equal to cv2.cvd color. First I want to pass the distribution image itself and then I pass the color code cv2.color underscore bgr2 gray. At the same time, we are going to create an empty mask that has same size of the frame. So here I'm going to type distribution mask equal to np.zeros like method, and here I pass the exact frame size. So I pass this variable, this grayscale image variable. And now come the face detection part using media pipe. Using media pipe, we extract facial landmark points from the live camera frame. So here I'm going to define a variable called distribution landmark point equal to get the landmark points. Here we need to pass the distribution image. Also we need to call a function from the media utils file, and our function name is get landmark points. I already create that function in my media utils file. So I copy the function name get landmark points and back to the app.py file, and here I'm going to access the function using its file name media utils dot get landmark points, and as an image source I'm going to pass the distribution image. As you know, our function going to find all the landmark points from the face and return all the landmark points, and I store the landmark points at that variable. Next we need to set a condition. If there is no face is detected, we need to skip this frame. For that I'm going to type if distribution landmark point is none, then inside the if condition I want to continue this loop. Continue. That's it. It's mean if no face is detected in the current frame, we simply skip it and move to the next frame. And once landmarks are detected, we convert them into numpy array and calculate the convex hull of the face. So let's convert into numpy array. So here I'm going to type distribution numpy points equal to np array, and here I'm going to pass the distribution landmark points to convert it into numpy array. Then after that, we need to extract the convex hull. And to get the convex hull, I'm going to define another variable distribution convex hull equal to cv2.convexhull method. And here we need to pass the array, this numpy array. You can think of the convex hull as a tight boundary that's wrapped around the face. After that, I'm going to create a blank image. And to create the blank image, we are going to use shape method. So here I'm going to type with height, width and channels equal to distribution image dot shape. It's going to create a blank image. Basically, here we try to create an empty canvas for the new face. And we are going to create the blank image exact size of distribution image. So I use distribution image.shape and it's return its height, width and color channels. Using it, we are going to create a new face. So here I will type new face equal to np.zeros method. And using the exact dimensions and color channel, we create the blank image. And our blank image name is new face. This blank image will act as canvas where we reveal the swapped face, and we do that triangle by triangle. Now let's display the source image and new face image. For that, here I'm going to type IamShow method cv2.IamShow. Then inside the round braces, inside the double quotes, I'm going to type the window name source image, and also I want to display the source image frame, source image, this one. At the same way, I want to show the new face image. So I duplicate this line, and instead of source image, I'm going to replace it with new face. It's empty, but I want to show that. Then I'm going to change the text of this window, new face. Then after that, I'm going to manage the keyboard input. So key equal to cv2.wait key. Inside the round braces, here I pass 3 seconds. I'm going to wait for 3 seconds. And then key equal to 27. Then inside this condition, I want to break the loop. Break. 27 is the key code of escape key. Then I break the loop. And after that, outside the while loop, I want to destroy all the windows. cv2.destroy all windows. Now let's set the file. Our program is not complete. Just I want to test is it work properly or not. After that, if I run this code in my terminal, it's going to display the source image. I want to say one of the source image from this image folder. Maybe it's going to show the first one, because here we run a loop and store the source image one after another to this variable. That's why it's going to show the first one, Bill Gates image. So let's run the code and see what is it returned. After run this code in my terminal, we need to wait for some time to display. So I'm going to waiting for some time, and then as you can see, in one window it displays the source image, Bill Gates image, and in another window it provide me the empty mask, the canvas itself. Also, still it read my face continuously. But here I do not show the live footage image because we do not create the window for that, and I don't need it for now. So our program is working fine. Let's back to the code. Hello guys, good to see you back. Once again, I am back with another chapter related to our project. And in that chapter, we are going to perform triangulation. We are going to apply triangulation both of the faces. So here, after that, I'm going to type a single line comment, and I'm going to type triangulation of both faces. So I'm going to start a for loop. So I'm going to type for triangle index in index triangles. Then inside this for loop, we need to perform the triangulation of first face. So here I'm going to type a single line comment, triangulation of the first face. Then to perform the triangulation of the first face, we need to call a function from the media utils file. We need to call triangulation function, this one. And this function take total 3 parameter. It is optional, but it is good to provide. So we need to pass triangle index, landmark point and image. And this function return total 4 variable, point, crop triangle mask and bounding rectangle. So let's back to the code, and here I'm going to call the function. To call the function, I'm going to type media utils dot triangulation. Then inside the round braces, we need to set the parameter one by one. In our first parameter, we need to pass triangle index. So here I'm going to assign triangle index equal to triangle index, this triangle index variable itself. After that, we need to provide the landmark points. We need to provide source landmark point. we need to provide the landmark point from the source image, because here we apply triangulation for the first image. So I'm going to type landmark points equal to source landmark points, and at last we need to assign the images. We need to assign the source images. So here I'm going to type image equal to source image. Now the question is, what are the source image? Source images are the images from the folder. As you can see, using the for loop, we append every image in our source variable. So from this source folder, from this image folder, we are going to access the images. And as you know, this function triangulation return triangle corner points, crop triangle from source image, and mask for clean blending. Also the bounding rectangle box. And to store it, all of it, I am going to define the variables. So here I am going to assign the variables name that are going to store all the value we get from this function, the triangulation function. At the same way, we need to perform the triangulation of second face. And the second face represent the user face. I want to say who's sitting in front of the camera. In our case, me. So first I'm going to type a single line comment, triangulation of second face. Then again we need to type media utils dot triangulation function. And as a parameter inside the round braces, I'm going to pass triangle index equal to triangle index itself. Then after that, after comma, here we need to pass the landmark points. But this time I'm going to pass distribution landmark point, not source landmark points. So I'm going to type landmark points equal to distribution landmark points. And as you know, we extract the distribution landmark point from our face. Here we read our webcam, and from here we extract the distribution landmark points. Now this function returns the same kind of result. To store it in a variable, I'm going to define the variables. So here I'm going to define the variables. This time I'm going to make it points to, and we don't need the crop triangle now, that's why I use underscore. Then we have crop triangle mask and the rectangle, the bounding rectangle. Now at this stage, both the faces are divided into identical triangle structure. And now we need to apply affine transformation. For that, we are going to use wrap triangle function. We need to apply this function. Let me show you. Wrap triangle. In this function, we need to pass the rectangle area, the bounding box rectangle area, points 1, points 2, also the source crop triangle and the distribution crop triangle mask. And it's going to return the wrap triangle. So let's do that. So here I'm going to type, after that I'm going to type media utils dot, here I'm going to apply wrap triangle. Inside the round braces, at first I'm going to define the rectangle. So I'm type rectangle equal to rectangle. Next we need to provide the points 1 parameter. And our AI already suggests me to do that, so just I'm going to press tab. So first we pass the bounding box rectangle area, then we pass the points 1 from the landmark points from the first phase triangulation, then from the second phase triangulation. Next we pass the source crop triangle area from the first triangle, source crop triangle, and at last we need to pass distribution crop triangle mask. So here I assign the value from the second triangulation, distribution crop triangle mask, and this function going to return wrap triangle. So we need to store it in a variable. Wrap triangle. This transformation wrap the source triangle so that it perfectly fit the shape of the destination triangle. Once wrapped, we place this triangle into correct position on the new face canvas. This process is repeated for every single triangles and gradually reconstructing the entire face. Next, we need to reveal the destination face. For that, I'm going to define a comment reconstructing destination face. And here, I'm going to call a function from media utils file. And our function name is addPiece of new face. And it takes total 3 arguments. New face, rectangle, bounding rectangle, and wrap triangle. So let's back to the app.py file. So let's call the function and provide the necessary parameters. So I'm to type media utils dot addPiece of new face. And here I'm going to pass new face equal to new face, and rectangle equal to bounding rectangle, and wrap triangle equal to the wrap triangle we get from the previous function. Now each wrap triangle is placed into new face, and by the end we get a full reconstructed face. After that we need to perform the seamless face blending. I want to say the final swap. For that we need to use a function, and our function name is swap new face, this one. So let's back to the add.py file, and here I'm going to type media utils dot swap new face, this one. And as you can see, in that function we need to pass total 4 parameters: distribution image gray, distribution convex all, and new face. So let's back to the code, and one after another I'm going to pass all the parameters. So as you can see, one after another I assign the parameters such as distribution image, distribution gray image, distribution convex all, and new face. And as I told you earlier, and this function create face mask from convex all. Also it uses seamless cloning function from CV2. Then it blend lighting and edges naturally. And as you can see, this function returns seamless cloning. So we need to store it in a variable. And to store it in a variable, here I'm going to assign a variable name. I'm going to assign a variable name called result. Result equal to media utils dot swap new face function. And this is our final result, and we are almost done. Now we are almost done. Just we need to apply little smoothness. For that, but before we need to make some correction, because we need to call it outside the for loop, not inside the for loop. Just using this for loop, here we just perform the triangulation. So outside the for loop area, I'm going to move the result variable outside the for loop area. That's it. Then we need to smooth the all artifacts. For that, I'm going to use median blur. So I'm to type result variable equal to cv2.median blur, and here I'm going to pass result itself, and I set blur value 3. Now let's create a window to display the result. So here I'm going to type cv2.imshowMethod, and inside it I'm going to type result, and I'm going to pass the variable result, and I'm going to set the file. Now let's run the code in our terminal and see is it work properly or not. So I'm going to hit the run button. After hit the run button, we need to wait for some time to start the webcam. Now let's wait for some time. So as you can see, it's worked perfectly. Here you can see on your screen, it opened total 3 images. It is the source face window, and it is the result, the actual result, and it is the new face mask. Now you can notice it swapped my face successfully. It swapped my face with Bill Gates image, and it is quite pretty accurate. Because of lighting problem in my room, you see some distortion, but it is successfully do its job. Let's control the light of my room and see. Yeah, now it's look pretty good. Here you can see the face mask, and here you can see the result. It swapped my face with Bill Gates face. And now we need to change the face. We need to apply another source image. And to do that, we are going to use our keyboard. So let's back to the code again. So I'm going to close the program and back to the code again. And now I want to change the source image when I press the numbers from my keyboard. So I'm going to type a single line comment, source image change. Now to change the source image, here we set a if condition. If condition using wait key method. Let me show you. So I'm going to type if ord 0 less than equal to key and key less than equal to ord 9, then inside this if condition, here I'm going to type number equal to int function, and inside the round braces I'm going to call character function chr character, and I'm going to pass the key key. Now the question is what we have done here. This block is a keyboard number selector. Key is expected to a key code. ORD0 to ORD9 checks numeric number between 0 to 9 in our keyboard. So if we press any number in our keyboard between 0 to 9, then it's going to extract the number and store it in a variable. Now how it extract the number? As you can notice, the key variable initialized with wait key method. So whatever value we press in our keyboard, it's going to return the key character code. And using character and key, we can convert the key code into character. After that, using int variable, we convert the character into integer and we store it in a number variable. So if I press 2 in our keyboard, then it's going to store 2 in the number variable. Now using that number, we are going to change the image. To do that, here I'm going to use another if condition inside it. Some type if number less than length of source images, then inside this if condition I want to change the source image. For that we need to call a function called set source image. So type set source image equal inside the round braces, inside the square braces I'm going to pass the exact number. And as you know, we defined that function set source image earlier in our code. Let me show you. This is the function set source image, and from here we are going to pass the images. We store the images in a list. So if I change the index number of the list, we can access the images using the numbers. So let's save the file and run the code again in our terminal. After hit the run button, we need to wait for some time to start the webcam. So I'm going to waiting for some time. So the first phase in our list is Bill Gates phase. Now let's change the number. If I press 1, now you can notice, now it blend my face with Steve Jobs face. And if I press 2, then it's going to change my face with Donald Trump face. But there is a problem. The problem is every face size, every image, source image size is different. And we need to reduce it dynamically. So let's back to the code again. So I'm going to close the program using escape key and back to the code again. Now from the every source image we need to extract the image dimension. I want to see the image shape. So here I'm going to type source image src image src image dot shape method shape, and this function return total 3 result: height, width and color channel. To store it in a variable, I'm going to type h as defined as height, w stands for width and underscore stands for color channel equal to source image dot shape. Here I want to ignore the color channel, so I use underscore sign. After that we need to extract the rate. I want to see the ratio. For that we need to use the target display width. So if I scroll up the page, now you can notice here we define a width 640. So I'm going to copy this variable width and back to the code again. Then here I'm going to type rate means the ratio, rate equal to, I'm going to divide width by width of this image w. That's it. So it's going to provide the ratio. W represents the original image width and rate is the scaling factor. Now using this ratio, I'm going to resize the source image. So I'm going to remove the variable source image and here I'm going to use resize method. So I'm going to type cv2.resize. Then inside the round braces, I'm going to pass the source image itself. Then I'm going to multiply width with ratio. Also I'm going to multiply height with ratio. That's it. And I'm going to set the file. Now without distortion the image, every source image going to maintain their ratio. And I'm going to set the file and run the code again. So after run the code in my terminal, we need to wait for some time, and after wait for some time, as you can see, it start my webcam. At first, they apply Bill Gates image in my face. My face is swapped with Bill Gates image. And if I change the index number, so I'm going to press 1, then it swap my face with Steve Jobs face. Then if I press 2, then it swap my face with Donald Trump face. Also, you can see the mask image, new face mask image at that portion in that window, new face window. Then if I press 3, then it change my face, it swap my face with Dwayne Johnson face, our rock. And if I press 4, now it going to swap my face with Will Smith face. And it quite pretty accurate, is not it? I know it is not perfect, but it doing so well. And if I press 5, there is no images that going to replace my face. So our program worked pretty fine. Thanks for watching this video. Stay tuned for our next project. I hope you enjoy that project. And last, I'm going to press escape key to close the program.